Okay, I'm going to talk a little bit about Svelte. So let me give a short presentation about who I am. My name is Anders. I'm a freelance software developer, and I love web development. I've been doing a lot of Angular development, and I love Angular, but it was perhaps getting a little bit heavy and a little bit stale. Things have changed over the last year, though. So I found something else to throw my love at, Svelte. Can you move this away? Here we go. Good. So the practical stuff, I have limited time. So if you have any questions, just hold them until the end, or you can come find me afterwards. And the slides are available at that link. They'll be at the end of the presentation as well, though. So these 20 minutes will be a bit about history, like the general term of history, about what Svelte is, how you can use Svelte, and then the next steps to take if you're really interested in what I have to talk about. I won't be able to teach you all Svelte. I'll be able to teach you a little bit about it, but hopefully it'll pique your interest. Okay, so all good histories start with once upon a time. Computers were huge. If we go back to the 50s and early 60s, these computers you were looking at were really big machines. They were using vacuum tubes. They would take up a warehouse floor or a small residential house. So not something you would have in your home because they would be your home. Okay, so in the 60s and 70s, you saw something new emerge. You went from vacuum tubes to microchips, and computers would become what they call mini computers. They would not be computers as we understand them today. They wouldn't have a screen and a keyboard. They would have teletypes, which are these printers with a terminal interface where you press keys on the keyboard and you would print on paper, send that data to the computer, and the computer would process it and write stuff out on paper. It would have very limited amounts of storage. And again, they would be relatively large. They could perhaps fit in a cupboard or a couple of closets. They wouldn't be an entire house. They would still be big, and nobody would have them, or at least companies would have them. The first computers would be big, they would be expensive, they would cost millions of dollars to build. The mini computers would go down an order of magnitude, so they would perhaps cost something like $100,000 or down to $18,000 the PDP-8 machine would cost. So that would be where the computers would be in a price range where companies could buy them. But again, private people wouldn't have them. So then you go to the 1970s, and I don't know if you recognize that machine. That's the first Apple computer. Design-wise, they haven't moved far from that. The same aesthetics, as you can see. So this would be the first time where you could have a computer for yourself. And when I say yourself, you would be a geek or nerd. We are all geeks and nerds. Now it's a positive word to use about yourself. Back then, not so much. If you'd have a computer, you would have it because you thought it would be really cool to have one, and you wanted to tinker with it. And when I say tinkering, it wouldn't be writing code. It would be basically soldering stuff onto a main board and building your own computer. And most computers would be in kits. So normal users could, of course, buy these machines, and they would come assembled. The first Apple computer would come assembled as a PCB board that you could hook up. But it would be difficult for a normal user to find justification to buy one, because what would you use it for? You wouldn't know. It would be a computer. Geeks said it was cool. You didn't know what you wanted it for. You would need something that would be a killer app, something that would justify you to spend a large amount of money on a computer. Again, computers were cheaper now, so you can afford them as a normal person. In the late 70s, early 80s, this machine would come out by Apple. It's the Apple II, which was one of their really great selling products, and it had a killer app, so everybody wanted it. The killer app was called VisiCalc, and it was a spreadsheet. So nowadays people would look at me and say, oh God, not spreadsheets. The entire world is run by Excel or online spreadsheets, and it's not very cool. Back then, this was the biggest productivity boost you could have. If you were working in accounting, you would be working on spreadsheets, but it would be on a piece of paper. So you would be doing a spreadsheet, and it would take you an entire week. If you had to change something, change a column, you would have to do the manual calculations, find your eraser, erase all the text on the paper, do the calculations, and you would do another week's work. This was a huge killer app because it would now do all the calculations for you based on input, So you could do something that had first taken a week down to a couple of minutes. There was one problem though, VisiCalc was slow. But that didn't really matter, because when you look at performance, it's always relative to something. You would say, you've never seen something like VisiCalc before, and you would have something that was very fast compared to the manual step, so it would seem very fast. Unfortunately, things in computers move really fast, and back then they would move more faster than it does today. The Apple II computer still existed, but the IBM or PC computers, personal computers, would appear on the 8088, 8086 processors. They would have much more performance, and this new spreadsheet app would appear, and it would run on the IBM PC or the PC clone. And it would, of course, be faster because the new machine was simply faster. But it was also faster due to other things. In VisiCalc, just imagine it as your regular run-of-the-mill Excel spreadsheet. You enter in stuff, enter in data into some cells, you enter formula into other cells. And when you update some of the cells or the formulas, you want to recalculate that. The problem with VisiCalc was that it wasn't very clever about it. It would recalculate everything. And being on a limited machine with limited hardware and performance, it would just be slow. Lotus 123 did things a little bit differently. They used something called reference forwarding, which is what the name implies. It would examine the formulas and the dependencies between cells and just do the calculations depending on where you change stuff. And that is reactivity, reacting to changes. If you're reactive, you're more performant. So there's an unfortunate truth I have to tell you, that all the most popular web frameworks today aren't fully reactive. I'm sorry, don't cry about it. I'll fix it in a couple of minutes. React is not reactive. You would assume it would be just by looking at the name, but it's not. It has a virtual DOM that is then analyzed against the regular DOM. So when you change something, you'll compare the two DOMs, traverse two DOM trees, and then manipulate it to see the changes. It's relatively performant, but it's not reactive, so we can do better. What about Angular? Angular is not reactive. Angular is probably worse than React, because in Angular you have it's a change detection mechanism. And if you understand that fully, please come and explain it to me, because I keep getting tripped up in the way it works all the time. The view engine is great. It's reactive. It's just detecting the changes that aren't reactive. So again, Angular is not reactive. What is Svelte? You can probably imagine what's coming next. Svelte is reactive. It means it's also simple to use, apart from the fact that it's reactive. It's fast because, as I said a couple of slides before, reactive apps are fast. So that sounds all good. So how's it simple? These reactive constructs we talk about are usually a bit complex to understand or reason about. React have hooks. If you understand hooks, great. But they can get confusing at times and lead to mistakes. Angular uses RxJS. That's not a simple framework by any means. So instead, Svelte has taken the approach that it'll just let the compiler do the hard stuff. And by letting the compiler do the hard stuff, it will basically analyze your code and just produce if statements from it. And as we know, if statements are really fast. And by the way, it's also simple to set up. So if you want to use TypeScript, it has that out of the box. Don't worry about it. Okay, it's also fast. So why is it fast? It's built on a fast tooling. It uses Vite for the builder, bundle, the environment. And Vite is fast due to a number of reasons. It does really intelligent bundling and processing of source code. It's also fast because you write simple code. And if you write simple code, you have to think a little bit less about it. And yeah, it's just fast. So I'll try to teach you Svelte. And Svelte is not that difficult to learn, but you need a reference. So all the examples, or most of them that I go through, will have a reactive sample, an Angular example, and then let's have a look at how you'll solve it in Svelte. I'm not going to go through all Svelte because, let's face it, yeah, we don't have time for that. Okay, so first and foremost, if you use Svelte, there's one simple rule. Svelte is a framework built for making components. It's not built for making single page applications, at least not out of the box. You need external dependencies for that, just like you do with React. But you're able to create components. So you create a component or one component per file. The components have to be named uppercase. You could probably name them lowercase, but it's not convention, so please don't. And the files have to end with the Svelte extension. And your file contains three main areas, if you like. It contains a scripting area that contains your JavaScript or TypeScript code. It contains your markup, and it contains some styling. And the styling is, of course, isolated from everything else. So every component you want to do needs to take input. In React, we know how to do input. You add a props to the constructor of your component, and then you're able to interpolate that into the JSX or TSX file. In Angular, you decorate your components with an input decorator, and then you're able to interpolate with a couple of extra scripted parentheses. In Svelte, it's a bit simpler. In your script, you say export whatever you want as an import. That's not logical, but that's the way it's done. And then you just interpolate it in the markup. And I know this is a bit confusing because we normally see export in ECMAScript modules when we actually want to export something. So you can say that you actually export an input. I don't know. That's how you do it at least. So very simple. Okay. So if we talk about input, we also need to talk about outputs. In React, I created a small example where I have a button. And when you click on the button, you can have a callback occur. And you basically just interpolate the function that you want to call back based on the other component, and it just works itself out. In Angular, you can create a component, have it output something based on the output decorator and creating an event emitter, and then just invoke that and basically have it output the event you specify. In Svelte, again, I hope you can read this. You create an event dispatcher, and then you just call that with the name of the event you want to emit. And of course, you can add payloads to that. You can do that with other stuff as well. And again, like 4 lines for the component emitting an event. And then as in React, you just interpolate the function you want to run on the output or the event when it occurs. You may want to have a look at, let's see if this works. No, it doesn't work. No one works on my Mac. Okay, I'll point instead. On : is basically a directive. So Svelte has very limited number of directives and you can't create them on your own. So on basically just says, just handle the event that occurs. So that's how you hook into that. And you can see that we dispatch the clicked event, and that's what you handle here, and then increment some counter stuff. Okay. I talked a lot about reactivity and how it was difficult in other frameworks. So again, in React, we use hooks. I won't go through this example in great details. In Angular, the developers lost their mind. That's my explanation. They do some really strange imperative code stuff where you have an interface you have to implement, handle some sort of strange object, and then do stuff. It works. It's just very verbose and manual. In Svelte, again, it's really simple because you use the compiler. If you have something, a button you click and you're able to increment the counter, this is what happens down here. When we click it, we increment the count variable, and then we print out the doubled value of the clicks down here. So when you want to do something reactively, you just prefix it with a $: which is a JavaScript label, and the compiler will then analyze what needs to be done to calculate the double value. So it will see, okay, I have a dependency on count. This is again reference forwarding as Lotus123 did it. And it will basically just create an if statement. So if count changes, let me redo that. Now this is really simple. This is just a statement, but you can have code blocks. You can have any statement you'd like really. And it'll just analyze the dependencies. And it works great. Just don't pull out anything you have after the reactive label into a function because the compiler can't figure that out. Is it okay if we go 5 minutes over time? I can talk fast, but you won't be able to understand it. So, of course, there are lots of other stuff. There's these logical blocks you have in the Svelte engine. React doesn't really have any support for statements because it outputs a value. So if you want to do something with an if statement, you basically have the ternary operator, or you can decide to return something based on an if statement, but it doesn't really have support for anything like if statements. In Angular, people again lost their mind. That's the pattern in Angular, or at least they thought, let's do this as extensible as possible. So they have something called structured directives, where it'll de-sugar whatever's in this attribute and then create templates and evaluate that. It works. It's not very elegant. So in Svelte, again, really simple stuff. You use the curly brackets to again say, let's interpolate some behavior. And there's different ways of looking at this expression language out. It's a block of logic or it's a beginning of a logic block when it starts with the hash sign, like here, the F statement. You can append to that logic block if it starts with a colon, like the square curly bracket colon, and then you basically end something with the /. So again, this should read relatively easy if you compared it to imperative code, like if, else, and then you have an end curly bracket at the bottom. You have loops. Again, React don't have loops because you return a value. So you have to do map, or you have to do other stuff before you return whatever your DOM is. Angular, again, unfortunately lost their mind and decided to do a structured directive. It works, but figure that out. Svelte, on the other hand, said, let's do a logic block. So let's just read what we have here. It's curly bracket, a hash sign, and then you have the each logic block. And it reads like the for auth or the for each statement in JavaScript. It does have one nice added feature. It has the support for an else block, which means if there's nothing in that members array, it'll just print the other stuff. So you don't have to nest an if and a each block. Again, convenience. The special handling for promises. It seems like both React and Angular lost the marbles there. I have no clue what's going on. I do, but I don't want to go through it. Read the slides, please, especially the Angular one. Svelte, again, takes the easy approach, created a logic block, has an await block, and it basically reads like imperative code, like await, then catch. That should make sense. Okay. As for data binding is not that difficult, neither in React or Angular. I think this is somewhat self-explanatory, apart from Angular. I'm sorry, Angular, I love you. Svelte data binding is, we talked about interpolating data into attributes, which is just the curly brackets, but this only flows downwards, which means that if you have a value in your script, you could say value equals curly bracket name, but it wouldn't go the other way. So you can use the bind directive here, and data will flow both down and up. It's reminiscent of the old AngularJS days where magic would happen and data would flow bidirectionally. Okay, and then you have state management. I decided not to go into examples with React and Angular because there are so many ways of managing state in Angular and React for that matter. When it comes to Svelte, they have one mechanism built in, which are called stores are reactive. They come in 3 variants, which are writables, readables, and derived stores. And if we just look at the example I created here, we create a store called name. That's a writable store. We're able to subscribe to the store, get a value, but then return something we can unsubscribe from whenever your component is destroyed. That's verbose. And don't worry, Svelte realized that's very verbose. So instead, you can look at the example down here and just say, just give me the store, or create a name store, and then let me just do all of this stuff automatically by adding a $sign to the beginning of the store. That way it will subscribe to the store for you, and it will unsubscribe when the component is destroyed. Again, magic using the compiler. And if you look at the contract, it looks like this. You have a store, you're able to subscribe, you have a set method. If you look at the subscribe method, you'll give it a subscription and you'll get an unsubscribe hook. And to me, it looks familiar. This is the story of it. If it looks like a duck and walks like a duck, and quack like a duck, it's probably a duck. So what I'm trying to say here is, is that the interface of the store is very similar to RxJS. So you can basically just say, get any RxJS constructs you have and plug them in, and they'll work. This is all great, and this has been very fast. If you think that Svelte is cool, please go and follow that tutorial. It's interactive, it's run in a REPL in the browser, learn.svelte.dev. And if you want to go even further after that, then have a look at SvelteKit. So SvelteKit is similar to other meta frameworks like Analog, Next.js, Nuxt, that just lets you create applications and provide you some really nice features like server-side rendering, static site generations, hydration of components, a lot of cool stuff. It's convention-based and just makes you much more productive. Have a look at that. Okay, I made it 6 minutes over time. And your minutes, yes. Okay, good. 5 minutes over time. Any questions? Yes.
Looking at this, it seems like there's a lot of non-standard syntax. What do you think about that? Durability and how do you learn Svelte?
So I get your point, but I have to correct you. The syntax is still JS. They're just using the syntax. The semantics behind the syntax is different. And it's a little bit confusing, but it's, so my point of view or looking at it is that it's just writing something that a compiler handles for you. So yes, you have to know how stuff behaves, and you just rely on the fact that the compiler will fix stuff for you. So yes, you learn JavaScript and you abuse constructs, but I think the payoff is that you have to do much less work. So I think it works out. Some people might not like it, but I happen to like magic. Yes. So this is probably something I should have said. Everything I taught you, forget about that because the new version of Svelte is coming out. And that's a lie. That's a lie. No, don't worry about it. So Svelte realized that their framework has problems. All frameworks have problems, but they decided to handle it. So they're coming out with something that handles details about timing, which this reactive $: statement is all about, is that if you want to do something, it will update at the very last end before impacting the DOM of the browser. So instead, they added something called runes, which are they're reminiscent of React hooks, but they are again accelerated by a compiler. And they are an addition to what you have in Svelte right now. And the guy who invented Svelte and was working on, Rich Harris, has said that yes, it's coming out, runes are coming out, but they will support the old standard for at least 2 major versions. Because you know that you can't just throw away all the code bases written in Svelte at the moment. Yes.
You had an example where you did the two-way binding with the bind colon value.
Yes.
Maybe could you just find that slide?
Maybe.
I'm just wondering regarding the value that you bind, because if that's exported.
Data mining, here we go.
Yes, so if you said export let name.
Yes.
Would that name property in whatever component that was using this,
yes,
would that also be updated?
Honestly, I don't know because I haven't done that. I think they'll just be asking for trouble.
Is that where you would use the store instead?
Yeah, you probably would. So if you have something where data is shared between components and they're suggested in between, you would probably add it into store instead, and you would still have data mediated reactively. So again, yes, there are places where you have to make sure you don't do really silly stuff, because honestly, I don't know how it behaves. I haven't done that yet because I could only see problems arising from it. Further questions? Anything else? No? Okay. Thank you for your time.